Yo, what's the deal? Welcome back to another episode of How to Algebra. In this particular video, I'm going to show you the fundamental theorem of algebra. So subscribe if you haven't done so already. Like, comment, hopefully you get something out of this. And as always, let's get it. All right, so let's get right into it. Fundamental theorem of algebra says that whatever the degree is of the polynomial, then that polynomial will have exactly that many zeros or solutions or roots, however you want to look at it. Whether it's a real number or a complex number, well, technically, all real numbers are complex numbers. So when we say that this polynomial has exactly 4 complex numbers, then it could include the real numbers as well. But I wouldn't get too hung up on that. Just understand that whatever the degree is, then that's how many roots it has, right? Exactly. Whether it's real or complex, whatever, we will 100% be able to find that many roots. So one thing to note is that if you're given a complex number, right, an imaginary number for the root, it's the way I teach it, the way I remember it, is that i's always come in pairs, right? You have 2 i's. So if I give you an I that's a root, well, then you need to find the other I. And finding it in the other I is actually very simple because it's a conjugate pair, right? So for instance, if here in the example, if you have a root that is 2i, well, or 2i, then its pair is negative 2i. Right? Because again, i's come in pairs. All right. I think going through 3 examples technically should be sufficient, right? Because again, if you followed along in the series, synthetic division has been in the last 4 videos. So this is just doing synthetic division, but now we can find all the roots. All right, so let's look at number 1. Given one of its zeros, find all the zeros of the function. So they're telling us that negative 4 is a root. That means x is equal to negative 4, which means that negative 4 is what's going in the synthetic division box. When you bring down the coefficients, we always check to make sure that the variables are in descending order, right? X cubed, x squared, and then x. So x cubed, this means that there's going to be 3 roots. Whether they're real, complex, whatever, we will definitely find them. So we're given 1. Let's find the other 2. So 1, 2, negative 3, 20. All right. At the end of this synthetic division iteration, it should be a remainder of 0. So negative 4. Again, I'm going to go through this kind of quickly because we should already be familiar with how to do this. Negative 2 times negative 4, positive 8. Plus negative 3 will be 5 times negative 4 is negative 20, which is in fact 0. Okay. Because this was x cubed, the original, right? The original. Now this is x squared and then x. So we have x squared minus 2x plus 5. All right, we see if we can factor it, right? Because we're still trying to find the 0, so let's factor it. Numbers that multiply to make 5 that add up to 2 are basically just 1 and 5, so that's not going to work. So we call this a prime quadratic, right? Because think about what prime numbers are. Prime numbers can't be factored. So a prime quadratic can't be factored, but it can be solved for 0 because we can use a quadratic formula, right? So this is going to be A, B, C. Quadratic formula says, right, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So x is going to equal negative b. B is negative 2. Plus or minus square root of negative 2 squared minus 4 AC. So 1 and 5. All over. And technically the x equals is not over. So all over 2 times a, which is just 1. Or a is 1, so 2 times 1, which is just 2. So simplifying, we see that x is equal to 2 plus or minus 4 minus 20 all over 2. Simplifying even further, we're going to get 2 plus or minus 4 minus 20 is negative 16 all over 2. Negative 16. So we have a negative inside the square root, so we can take that out as I. So square root of 16 is 4 I over 2. Right? We can reduce this one last time because there's a 2 in everything. Right? We can cancel out the 2's. They become 1's. And then the 4 becomes a 2. So final answer, 1 plus or minus 2i. So our roots are x equals negative 4. That was given. X equals 1 plus 2i. X equals 1 minus 2i. All right, so synthetic division once using the roots. And then when we get down to a square or a quadratic, you can use quadratic formula or factor. Okay. A little more involved problem. So the given root here is 5 minus I, right? This is a complex number for sure, right? Because I is an imaginary number. So i's always come in pairs. So we know that the next root is going to be 5 plus I. 5 plus I, right? So you always switch the sign on the I, the imaginary part, never the real part. So I can use either one of these roots. I know it looks awkward. 5 minus I is what's going to go in the synthetic division box, right? Because it's just a number. We're putting a number in there. Technically, we're putting the root in there, right? Because this is x equals. And we ensure that the exponents are in descending order, which they are. So we grab the exponents. Negative 15, 70, negative 70, negative 156. Okay, so the way this is going to work is, just like before, we're going to multiply, add. Hopefully the remainder will be 0 because they're telling us that it's a root. And then we'll do synthetic division again. So 2 iterations of synthetic division. And the first one's going to suck. The second one is way easier. So we just got to get through the first one. Bring down the 1. Multiply, just like normal. 5 minus I. So I know it looks intimidating, but we add just the real part. So negative 15 plus 5. Negative 10 minus I. Here comes some side work, because when you multiply, right, we have to multiply these two things. This is 5 minus I, negative 10 minus I. We have to do FOIL, right? Distribute. So 5 times negative 10, negative 50. 5 times I, negative 5I. I times negative 10, positive 10I. And then negative times negative is a positive, I squared. Remember, I squared is equal to negative 1. So this is equal to negative 1. So the sign's just going to change. Combining like terms, we get negative 50 plus 5I minus 1. So negative 51 plus 5I. Negative 51 plus 5I. Okay, adding, right, because we have to add going down. We add 70 minus 51. 19. plus 5i. Okay, start over. Side work again. So this is going to be 5 minus I, 19 plus 50, or 5i. 19 plus 5i. So 19 times 5, 95. 5 times 5, positive 25i. Negative 19i, negative 5i squared. Okay, combining like terms, 95 plus 6i, and then I squared is negative 1, so it's going to change the sign. So we're going to get 100 plus 6i. 100 plus 6i. When you add, we're going to get 30 plus 6i. Okay, this last iteration, we know that this needs to be 156, but we have to verify. So this is going to be 5 minus I, 30 plus 6i. 5 times 30 is 150. That's looking good. Then plus 30i minus 30i. That's nice. They're going to cancel. Let's do it right now. And then lastly, plus 30i squared. Or not 30. That's going to be, wow. That's going to be I times 6, which is negative 6i squared. But I squared is really negative 1, and it's going to flip the sign. So 150 plus 6. Right, this is really negative 1. So we got 156, positive. And that's what we were expecting. Okay. We have to go through it one more time using the other root. So 5 plus I, that's what going into the synthetic division box. And now it feels like, oh man, we got to do this again. But the second time, all right, but the second time you go through, it's way easier. You'll see. So we bring down the 1. We multiply. So 5 plus I. When you add, look what happens to the i's. The i's go away, and just the real part is going to be negative 5. We multiply, we're getting negative 25 minus 5i. Again, the imaginary parts cancel. The real parts is just negative 6. Again, multiplying, we're going to get negative 30 minus 6i. So we're going to get 0. Okay, so this is going to be x squared and x. So x squared minus 5x minus 6. So can we factor this? Two numbers that multiply to make 6, negative 6, that add up to negative 5. So we have 1 and 6, 2 and 3. Well, both of these can make a 5, but only one of them is correct. So negative 6. One of them must be negative. It must be the big one. So it's definitely not this one. So 1 and negative 6. So our roots are going to be x equals negative 1, x equals positive 6, x equals negative 5 plus negative 5 plus I, and then x equals negative 5 minus I. Those are the 4 roots. Okay, and the last example, kind of working in reverse. We want to write a polynomial, and we're given the roots. So we're given 2 and 4i. This means x is equal to 2 and x is equal to 4i. Now remember, i's come in pairs. So if you give me an I as a root, I immediately know the other root. It's going to be its pair minus 4i. So now we take the roots and we turn them into factors. Right, x minus 2 is a factor. X minus 4i is a factor. X plus 4i is a factor. And we just FOIL all these out. I personally like to start with the complex numbers because they're conjugate pairs, right? They're identical, except for they differ by one's negative, one's plus. So conjugate pairs, when you FOIL them out, it's just the first and the last only. So x times x is x squared. Negative times negative is a negative. 4 times 4 is 16. I squared. I squared is negative 1. So it's just going to flip the sign. X squared plus 16. And we have to multiply that, distribute it to x minus 2. This is going to be x cubed plus 16x minus 2x squared minus 32. And you can write it in descending order, or this is fine. But technically it's x cubed minus 2x squared plus 16x minus 32, right? If you want to write it in descending order. Okay. Hopefully this was helpful. You get something out of it. Subscribe, like, comment. I want to read your comments. So I'll catch you later. Peace.